Welcome. Today's lesson is on logarithms. First we're going to cover the definition, and then we'll talk about how it's related to exponents. That will also cover a graph, because the graph of the logarithmic function is very related to the graph of the exponential functions. We'll cover the rules. Remember, exponents have their own rules. Logarithms have rules that are very similar because they're so strongly related. Finally, we'll use an example that hopefully puts a lot of it together. So first, though, we need the definition. What is a logarithm? Well, the logarithm is a new function. What it says is the log base b of x is y. What does that mean? It means that x is b raised to the y power. What is that really telling you? It says we're asking for how many powers of b does x have in it. So let's do an example. Log base 6 of 36. How many powers of x is this 36? Well, I'm sorry, how many powers of 6? That's 6 times 6. There's 2 powers of 6. Let's try a trickier one. Log base 10 of 1,000th. Well, if you remember your rules for exponents, a number in the bottom of the fraction has a negative power involved. This is 10 to a negative power. How many 10s are there? It's 10 times 10 times 10. So that's 3 powers, and it's on the bottom. So that's a minus 3. Now, what about this next one? Log base 4 of 2. You might be tempted to say, well, 2 squared is 4. But remember, we're actually asking right here, 2 is 4 to what power? Well, 2 is the square root of 4. And if you remember your rules for exponents, square roots are fractional powers. So the answer here is 1/2, because 2 is 4 to the 1/2. Now, how does that relate? Well, clearly, these are very strongly related. They're the same thing. This is a logarithmic definition. This is an exponential definition. So the graphs are related. In fact, look, the x and the y switch. This is an exponential, but the x and the y are reversed. So that means we reflect along the y equals x axis. I'm sorry, the y equals x line there to get the new graph. Here's y equals b to the x, and reflecting mirror image along y equals x gives us a logarithmic graph. This is what the log looks like. Now, what does that all mean? There's an important consideration here. Look, nothing over here for the blue graph. The logarithmic graph can't take a negative in here. Why? Because you can't have a negative over here. B to the y, if b is positive, and y is positive or negative, it doesn't matter. If b is positive, this is positive. You can't have a negative x. You can't put a negative in here. You can't even put 0 in here. The domain of the log base b is only the positives. So let's take a look at the rules. They're very much like the exponential rules, just reversed. Log base b of x times y is going to be the log base b of x plus the log base b of y. And the same with the y. Log base b of x divided by y is log base b of x minus the log base b of y. Next rule, log base b of x over y. Now this is the most important rule. Logs allow us to take this power and pull it down in front. So we get y times log base b of x. Then we get other rules. Log base b of 1 over x is with a negative in front. Log base b of b to the n is n. Log base b of 1 is 0. And there's important definitions. If you ever see the log without a number there, that number is implied as a 10. That's just standard. And if you see this ln, ln means natural log. It's not an in, by the way. It's never an in. It's an ln for log natural, because the people who developed this were French, and they like to put their adjectives at the end instead of the beginning like we do. So that's log base e of x. And then there's a rule called the change of base rule. If you don't like your b, you can change it to a c this way. Log base c of x over log base c of the original base. And the last and important rule says log base b of x equals log base b of y means x and y are the same thing. The log is a one-to-one function, so this works. How do these rules all help? Well, let's take a look. I want to know what x is will make this whole thing true. Log base 3 of x plus 4 minus 2 times log base 3 of x minus 2 is 0. Okay, so how do we solve that? This 2 here is that 2. We can use this rule to put it in the top. So what do we get? Log base 3 of x plus 4 minus log base 3 of x minus 2 quantity squared is 0. What about that minus? That minus is like this second rule. We can combine them as a fraction. We have log base 3 of x plus 4 over x minus 2 quantity squared is 0. Now, we have the log base 3 of something is 0. What does that tell us? Log base 3 of something is 0. We could use the definition, or simply tell us that x plus 4 over x minus 2 quantity squared to 2 is 1. Why? Because it's actually 3 to the 1. 3 to the 0. 3 to the 0 is 1. Now this has no more log in it, so we can solve it quickly. I can multiply it by the bottom. X plus 4 equals x minus 2 quantity squared. What do I do now? I multiply that out. X squared minus 4x minus 4. Now I've got a quadratic. There's no logs, it's just a quadratic. Bring the x, bring the 4, I get 0 equals x squared. Subtract next, so minus 5x. Subtract 4, minus 8. That should factor, I hope. Let's see. I need two things that factor with minus 8. Like a minus 4 and a minus 2, no? It doesn't seem to factor. What about a quadratic formula? Will that work? Well, something's wrong.
When you FOILed it out, it should be plus 4 at the end.
Aha! See what happens? That's why you have a camera person, to catch those little mistakes. So this goes away. Why is that important? Because 0 equals, see, even a math instructor can make mistakes. Factoring is a tricky thing. So we get either x equals 0 or x equals 5. But we're not done. Because 0, put a 0 in here, 0 minus 2. What's the log base 3 of minus 2? Remember, you can't do that. This is what's known as a false answer. That, however, will work. So, having shown that it can be done, and that it can be tricky enough to sometimes fool even a teacher, that's all we have for today.